right, now we have the next set of questions here. We have the natural log of e squared equals x, and so changing this into exponential form. We have base e, because natural log, so base e to the x power is equal to e squared. And so what would x be? Well, x would be 2. All right, here we have the natural log of the cube root of e is equal to x. And so, again, remember natural log means a base of e. So e to the x power is equal to the cube root of e. Actually, I'm going to, well, I guess you can, yeah, I'm going to rewrite this cube root as its exponential power, and that's going to be, right, we'll leave it in there actually. Cube root of e, that's the same thing as e to the 1/3. So remember your fractional exponents. And if e to the 1/3 is equal to e to the x, what does x have to be? Well, x has to be 1/3. All right. Next we have log of, log of x squared minus 1, that quantity, equals 2. So remember, what is your base? Well, our base here is 10. So we have 10 squared is equal to the quantity x squared minus 1. X squared minus 1. And so if we were to actually evaluate it, we have 10 squared, that's 100, is equal to x squared minus 1. We would add 1 to both sides to get 101 is equal to x squared. Take the square root of each side, and we get x equals positive or negative the square root of 101. Now, x is, this positive or negative here isn't a base, so we can have, that's just the x value, so it's okay to have a negative here. Oh, this is a good chance to talk about not taking the log of a negative number. Not taking the log of, say, example, negative 8. So if I had log base 10 of negative 8, this isn't something we can do, because remember what a logarithm does. It's talking about the exponent. So if I have 10, it doesn't matter what the exponent is, I can never make this equal to either 0, because the exponent's either going to make it much higher or make it exponentially smaller but still positive. For example, it might be 1 over 10 times 10 times 10 times 10. Maybe it's 10 to the negative 4th. These two would be equivalent. And all that's happening is that it's getting closer and closer and closer and closer to 0, but it's never going to actually get there. Not only will it never get there, it'll never get negative either. So we cannot take the log of either a negative number or of 0. So it's just kind of a thing to keep in mind. Because remember, what what logarithms we're talking about is what's happening with the exponent. Just remember, an exponent can't make it equal to 0 or negative. All right, let's take the next ones in the next video.